Say, suck it up. So this is 3-7. Logical arguments. In other words, we're going to become lawyers again.
I was just like, how can you have an argument about something that don't make no sense?
But if you put it in writing, it's guaranteed to be either true or false. And it has to be one or the other. So this is how logical arguments are written. If I give you a statement, a sentence, and this sentence has to be true. In a logical argument, the sentences I give you to begin with have to be considered true. Have to be considered true. So if you pass this test, then you will pass this class. And it has to be a true statement. So what happens if you do not pass this test? Then what must be the other half? You didn't pass the class or you did pass the class. Remember, if it's false in the beginning, it doesn't matter if it's true or false in the end. But if you pass this test and you do not pass this class, then this must be a false statement, which in other words, it can't happen because this has to be true. So this is what's considered a logical argument. This is like a contract that you signed with somebody, and the sentences in the contract have to turn out to be true. Because if they become false, then the contract becomes broken. It's a broken contract or invalid contract, depending on which side you're on. Then I give you another sentence, a condition, another possibility. Of something that actually happened, so this also has to be true. That something happened after the contract was signed. Okay? And we're going to separate these from the conclusion. So this is a conclusion. This is called therefore. You know, mathematicians are lazy, so instead of writing therefore, they write 3 dots in a triangle. So when you see 3 dots in a triangle, you read the word therefore. This is also known as a conclusion. And all we're going to kind of determine is if the two sentences, let me say this in English now, if the 2 sentences on top are necessary to be true, does that make the bottom one true?
No.
My conclusion. And sometimes it does, and sometimes it doesn't. So my conclusion here is, you passed the class. Do the first 2 sentences force the bottom one to be true? Force it. Now, where the top 2 sentences have to be true, this one can be true or it can be false, depending on a lot of things. So if it's true, then we consider this entire argument valid. If it's false, then we consider the whole argument invalid. Or if we can't determine if the bottom one is true or false, then it's also invalid because it's not forcing it to be true all the time. All right, so once I give you the argument in English, what do you think you need to do? Got to change it into symbolic form. So simple statements. P. Yeah.
I don't understand it.
I haven't done anything yet. I just wrote down a bunch of words.
I don't understand the words you just wrote.
If you pass this test, then you will pass. That's not what we mean. So what don't you understand? I've just set up something. I haven't done any work. This is something that is given to you. Top sentence is true, middle sentence is true, the line separates it away from the conclusion. That's all I've said.
How did you pass the class?
That's just the conclusion. I give it to you. You do not figure that out on your own. Now, you should be able to look at this and kind of come up with somewhat of a conclusion. But for the first ones, I'm going to give it to you. So, P is?
You pass the test.
Passed test. Okay. The second one is?
You will pass class.
You pass the class. Is there any third statement? No. All this has to do is passing a test and passing a class. Even if the small words change, like up here it says the student passed the test, and then I say you passed the test, they're talking about the same thing. You're passing a test, so that's still one singular idea.
So why you got it in ED, past tense?
Doesn't matter.
Okay. Because I have something different.
That's what I'm saying. As long as they mean the same thing, the word's really irrelevant.
Okay.
So if this one says a student passed the test, and then down here it says you passed the test, they're talking about the same thing. So words are irrelevant, ideas are the important part. All right, now I need to set up this entire argument in symbolic form. So the top one is, if you pass the test, then you'll pass the class, which is P, arrow, Q. The middle one is, you pass the test. You pass the test. It's Q.
Wait a minute, we ain't had number two statements. Where you going?
That's what I'm saying. If you pass the test, then you'll pass the class. If you pass the test, then you'll pass the class. You pass the test. P, thank you. I was wondering. Line, just like that one. 3 dots for therefore. You pass the class. Q. So this is my logical argument in symbolic form.
Oh.
What did I do? I haven't done anything that I haven't taught you before. I've taken each one of the sentences and wrote it in symbolic form. You're acting like it's rocket science all of a sudden.
It is.
It is not.
To us.
I took the black and I changed it into the blue. Woohoo! Alright, now the next one is a little bit of rocket science. I'm going to put the top in parentheses because it is 2 pieces, and I'm going to call it...
Top.
That sounds obvious, right? I'm going to take the middle and put it in parentheses, even though it really doesn't need it because it's only 1 letter. But I'm going to do it anyways, just in case there's 2 of them.
Stop.
We're going to put this as...
Meeting.
It's not a bottom. Good Lord. Yep, that's in the bottom. And then the same thing, the Q is the bottom. My Lord. Alright, and the way we're going to write this is, the argument kind of reads top and middle, then the bottom. Literally, that's how it's going to read in logical form. Top and middle, then being the arrow, right? The bottom. So we're going to write
all of them?
P arrow Q and P, then
Q.
Q. Now I don't need parentheses around the P or the Q, but I'm going to put them in here first for the fun of it. So it's always going to be top and middle. Got me saying it now. Arrowed off to the bottom. Now there's a problem. There's 3 pieces here. It only works on 2 pieces. So I need to do some grouping. Where's the grouping going to go?
P and the Q.
The P in the top part. So the top and the middle are going to be separated from the conclusion. They're going to be separated from the conclusion. So this is the setup for every logical argument. It's going to be bracket, top and middle, bracket, arrowed off to the bottom. If there's 3 things on the top of the line, then it would just be this one and this one and this one. Put them all together, arrowed off to the bottom. I don't do that. So what can I do with this symbolic form of an argument? I can find its truth table. So we're going to do a truth table. How many lines is it going to have?
2 remaining. What?
How many lines
8.
down?
4.
4. You only get 8 when you have 3 letters. We only have P and Q. So you're going to have 4 lines. 8. 4 lines down. Where do I start? Start inside the brackets, and then start inside of the one of the parentheses. So here, start with P. P is TT, FF. Move over to Q, TF, TF. In between them is an arrow or a conditional. We're looking for a T and then a F. This becomes F. And the rest of them are true. So this is true, this is true, this is true. Where do I go from here? Where do I go? To the P. What color?
Red.
Blue. Why is it going to be blue? Because it's going to go together with the last answer over here, red. So P is true, true,
True.
false, false. What's between these two blue columns?
And.
TNT.
We're looking for two truths, make it true.
So the first one be true, the rest of them be false.
The rest of them are false. So, that TFFF in the middle there is the final answer to the left-hand side. I go over to the Q. What color?
Green.
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 Which is? T.
TFTF.
TFTF. T, green. F, green. Do you see it?
No.
So this is all true.
I do that.
Oh.
Now, since it's all true, the argument must be
True.
Valid.
Valid.
valid. That means that conclusion has to happen under these conditions.
I gotta buy.
So, the top two statements, given, and they have to be true. Therefore, my conclusion, I don't know about my conclusion.
You gonna make it false.
You think?
So whenever they have the conclusion, you don't know if it's true or false till after you do your table.
True.
Okay.
Or correct, I really should say. Have enough truths and falses going on. Same idea. You set it up. You start with your simple statements. And don't forget your P and Q when you write your simple. P.
Rabbit lives in Arctic.
Rabbit lives in Arctic.
It is white.
Rabbit is white. You could write it, as long as you know what it is.
Now I need to do a table.
It just gets confusing. Before you do a table, you've got to change the whole argument into
bottom,
symbolic form. So, if a rabbit lives in the Arctic, then it is white becomes
P.
P,
Arrow.
arrow,
Q.
Q. My rabbit is white
P.
Q.
is Q.
Q.
Line, because that line's up there. Therefore,
Therefore,
my rabbit lives in the Arctic.
P.
P. And you change it into a table exactly the same way. Top and middle arrowed off to the bottom.
Bracket.
But be careful, if there's two pieces, they have to go inside of...
Bracket.
No, their own little parentheses. But it starts off with bracket, top, and middle, arrowed off to the bottom.
Now I do my truth.
How many lines?
4.
4, because it's only 2 letters. Okay. So start with P. This is true, true, false, false. Q is
TLT.
true, false, true, false. We're looking for
T and F.
a T and then an F.
And then it's the second one.
The second one. So this is false. Everybody else must be.
True.
Because it's the only TF that happens. Then I move over to the Q. What color?
Black.
Blue.
Blue, because it's going to go with the last answer on that one. The last answer on this one was blue. He's going to go with it, so he better also be
TFT.
blue. Now I take the 2 blue columns and I put them together over the,
TLT.
and I'm looking for 2 trues. So the top 2 are true, and the third line down are both
True.
true, so that's true. The other 2 must be false. So we get TF, TF. Am I done?
No.
Nope. I come over to the P, way over on the other side. What color?
Green.
Green, because that's the last thing I did over there.
Okay.
So this becomes true, true, false, false. And it's a conditional, so what are we looking for? A T
And now.
and then an F, which makes it
False.
false. Once you land on one false, you are done. You don't even have to put trues for the rest of them. Because I landed on one false, this argument becomes
False.
invalid.
Invalid.
Just because my rabbit is white does not force me to live in the Arctic. Does not force me to live in the Arctic. So this argument is
So you
invalid.
point an arrow just like that, sir.
You put a circle on one F in this table, in the final column, just one F, you could stop and just write invalid. If it has more F's, that's irrelevant. Once you find one, it's invalid. The only reason it's valid is if every single one of them is true. It has to be a total true. The bear will run. Yeah, the bear will run away, or we will be hurt. We are actually hurt, therefore the bear ran away.
We change it into symbolic.
We could care less if it makes any
sense.
sense. Generally, most of these don't. So, you just take whatever's there, change it into symbolic form, and see what happens. So, P, bear ran. Q, we hurt. And change it into symbolics. The bear will run away, so that's P. Or, we will be hurt, Q. The second line is, we were hurt, Q. Therefore, the bear ran away, P. Don't ever guess on these. Don't sit here and go, oh, it's valid, oh, it's invalid. Because sometimes it's really hard to tell one way or the other. The book has little shortcuts. I highly suggest you don't use them. Because they will confuse the heck out of you. So, the top line is going to be bracket, parentheses. Remember, there's two letters, you got to put parentheses around them. P or Q. And Q, bracket, arrow off to the bottom, which is plain old P.
And then I do a truth table.
And then do truth table 4 lines.
So I'm going
We'll only have one 8-liner. And actually, I'm going to shortcut that one to death. So where do I start? P. It's always a good one to start with. True, true. False, false. Be careful. If the original sentence has the word not in it, there's got to be a tilde over here someplace. So be cautious with that. Q. True, false, true, false.
That is or, so you looking for
Or.
two F's to be false.
Only
False, false.
only false when both are false, which is this last one. Everybody else must be true.
So then I go to the Q, right?
What color?
Pink. I mean blue.
Pink. I don't have pink.
I got pink.
Blue. So this is true, false, pink. Up to you. And between them means only true when both are true.
So I change.
So this is true. This one's true. And the other two are false. Just looking at the blue ones, nothing
P
else.
with green.
P with green is true, true, false, false. And right here, same idea. This one is invalid.
And that's it.
Would it have helped if the bear didn't run away? Then this would have been false, false, and this would have been true, true, but then you still have a T and a F. So it's irrelevant whether the bear ran away or not, the argument would still be invalid. Which is kind of cool if you think about it. For example, let me put it in black. That's not black. If it snows in Maine, then there is rain in Florida. If there is rain in Florida, then it is a hurricane. Therefore, if it snows in Maine, then there is a hurricane in Florida. Guess how many of these are on the test?
One.
No, I need one. Takes too long. Thank God on the test it's all typed up, so you don't have to write out the entire sentences.
Right.
So, how many ideas are here?
3.
3. So we're going to have a P, a Q, and an R. P is snow
In May,
in Maine. Q is
rain and rain.
rain in Florida. And R is? No, it's not.
What is it? I don't know.
Snow in Maine.
No,
And
Hurricane
hurricane.
in Florida.
the hurricane. Hurricane
What's that? What are you doing with it?
in Florida.
That's what she said.
If it snows in Maine, P, then there's rain in Florida, Q. If there's rain in Florida, Q, then it is a hurricane. Hurricane's different than snow and rain, so it's got to be the third one. Okay, symbolic form.
Okay.
What about the if then?
You don't put
Never
that
mind.
into simple statements.
I said never mind.
Okay.
So, first sentence. If it snows in Maine, then there is rain in Florida, writes down as P arrow Q. If it rains in Florida, then it is a hurricane is going to be
Q.
Q arrow
R.
R. Therefore, if it snows in Maine,
P.
P
Arrow.
arrow, then there is a hurricane in Florida, R. Now, you can, if you wish, and some people do on the test, do a truth table for this. The problem with that is you'd have bracket, parentheses, P arrow Q as the top, and Q arrow R as the middle, arrowed off to P arrow R as the bottom. How many lines is it going to have? 8. That takes too much time. There's an easier way to do it, and it's really easy to figure out if it's valid or invalid. And the technique works this way. Number 1, there has to be a diagonal in the argument. What I mean by a diagonal is, if you look on the top part, it looks like a box. You know, you got this little square. You know what a diagonal is, right?
Yes.
If a diagonal goes through the same letters, like for instance here, these are both Q, you're starting to lean towards it's valid. But that's not the whole thing. It just has to have a diagonal first. The second part, part 2, is what's left, what was not crossed out, drops straight down. Whatever's left after you cross those 2 out has to drop straight down in the argument. In other words, did this P fall right into that first position? Yes. Did this R fall into the second position? Yes. Then this argument is valid. And you're
And it
done.
only works for the 3.
It only works for 3 conditionals in a row.
Is that always
If you put an and or an or in there, all bets are off.
It's always gonna cancel out like that?
Now let me give you possibilities.
Oh.
Possibilities. If you have P arrow Q, R arrow Q, over therefore P arrow R,
Just invalid.
this is invalid because
There's
there's no diagonal. The Q's are right above one another. That's not a diagonal. So this is invalid. So if the sentence was snow in Maine, then there is rain in Florida, hurricane in Florida, then there is rain in Florida, this would become invalid automatically. All right, we can get tricky with this. What if I have P arrow Q and R arrow not Q, therefore P arrow not R?
That's not.
Is this invalid?
Yes.
Yeah.
Well, you can't tell because there's no straight line or diagonal. The only letter that's similar is Q and
Not
not Q. Is there any way of changing this so one of them is not Q or the other one is real Q?
March's law.
Well, it's not De
The
Morgan's law.
Morgan's law.
It's a conditional. What's equivalent to a conditional?
Or
Equivalent to a conditional, as a conditional itself. You know, there's inverse, there's converse, and there's contrapositive. Contrapositive. So if I find the contrapositive of this one, do the contra. This argument now becomes P arrow Q for the top. What's the contrapositive of R arrow not Q? Q arrow
Not R.
not R. Therefore,
It's conditional.
P arrow not R is this valid?
Yes.
Yeah, because now there's a diagonal, and the P drops straight down, and the not R drops straight down. So this is valid.
But you also, I still can make my table if I don't get
Yeah,
all
if you don't want to go that direction, you can make a table, go through the 8 lines down, 11 lines across for a total of 88 truths and falses.
So if we do,
So when we do
No,
the
no.
contrapositive, all we do is just flip it and then.
Part of this technique is you have to have a letter that is exactly the same. You can't just leave it as Q and not Q. You have to force them to be exactly the same before you say it's invalid, before you say it's valid. Does that make sense? So I can't cross off a Q and a not Q. That doesn't make any sense. So I'd have to do the contrapositive. Contrapositive is the only one that works.